Hey guys, it's Jennifer from Breakthrough Maths, and today I'm going to be showing you how to factorize using highest common factor. So here is our question. First of all, we need to look at how many terms it has, and we can see it has two terms. So this is our first term, and this is our second term. So anytime there's a sign like a plus or a minus, that moves you on to another term. So we can see we have two. Okay, so what are the implications of this? Well, we know there's four types of factorizing. There's highest common factor, like we're going to do now. There's difference of two squares, quadratics, and grouping. With two terms, there are two different types of factorizing that it could be. It could be difference of two squares, or it can be highest common factor, like this one is. But how do we know whether it's difference of two squares or highest common factor? Well, that's what I'm going to show you now. So this is really important. If you have two terms, like you do here, it can either be difference of two squares, or it can be highest common factor, HCF. But you must check for difference of two squares first. So that is really, really important. You have to check for difference of two squares first. Well, how do you do that? Well, it means that each of your numbers need to be whole numbers. So your numbers need to be whole. And your letters need to be squared. So when I say your numbers need to be whole, that's after you've gotten their square root. So if we get the square root of 12, you will see in your calculator that that is 3.464, and that is not a whole number. So that means that this cannot be difference of two squares. But if we were to look at another flaw, we can see here, this y is not squared. And we see here that all letters need to be squared. So because our numbers squared, we tried 12, that square root of 12 did not give us a whole number. It gave us a decimal, 3.464. And we can see here that our y isn't squared, and we can also see here x isn't squared. So we've checked there and we've seen multiple reasons why it is not the difference of two squares. So now we know it must be highest common factor. Okay, so now we move on to the highest common factor, now that we know it is not difference of two squares. So what we do is we have to take out our highest common factor between both of these terms, starting with the number. So the highest common factor for 12 and 8 is going to be 4, because 4 divides into both of them. Then we look at our x and our y, our letters, and we can see that there's an x and a y common between both terms, but only one x and one y, because here there's only one y and here there's only one x. So we don't have x squared or y squared as our highest common factor. So that's really important. Then we open up a bracket and we need to get back to the question we started with from 4xy. So starting with the numbers again, to get from 4 to 12, we have to multiply by 3. And to get from xy to x squared y, we're missing another x. Then we move on to our minus 8xy squared. To get from 4 to minus 8, you need to multiply by minus 2. And to get from xy to xy squared, you're missing a y. And that's your final answer there. And that's how you do factorizing using highest common factor.